Welcome back to Room DE. I want to thank our sponsor, Permiso. Permiso is a threat detection company that finds evil in cloud-based environments. Detection in identity, cloud, and SaaS environments has suffered too long from a one-size-fits-all SIEM approach. Modern environments require a purpose-built platform. Permiso uses human and non-human identity attribution to pair runtime and static data in the cloud and SaaS into complete sessions where detection no longer has to rely on a single event and no context. Permiso's platform provides high fidelity, high resiliency, and maximum context for actionable detections that cut through the noise. By analyzing human and non-human identity entitlements and behavior across authentication boundaries, Permiso gives companies a complete picture of every entity in and operating across their cloud environments. It does not allow threat actors to hide in silos of overwhelming cloud activity data. And now I'd like to welcome Chen to the stage, who's going to talk about taking over VMs the cloud-native way. Welcome them to the stage.
Thank you. Hi, my name is Jay. I am a researcher with Prisma Cloud and Palo Alto Networks, and my research focuses on identifying the risk in the cloud and threat against the cloud and turn them into security rules or policy for our products. And I am also the author of our annual cloud report, in which we highlight the threat, risk, and hype of the cloud in the period of time frame. When I'm not working, I'm a dad of two. I spend most of the time with my kids. My super hyperactive kids keep me busy and entertained most of the time. And I'm also a cat lover. During the meeting, I usually spend a lot of time scrolling through funny cat videos. So let me step back a little bit and explain a little bit the motivation of this research. There were a few times that I was locked out of my VM because I couldn't find my SS keys. And usually I end up just shutting down those VM and move on. Luckily, I haven't lost anything too critical, but this experience made me think, is there any other way that I can regain control of my VMs? After some research, I found quite a few methods, which I will talk about this today. So on the one hand, this method allowed me to regain control of my VMs. On the other hand, this method can also allow attacker to gain unauthorized access to my VM, unauthorized access to my VM without SSH keys. So VM service is one of the oldest service in the cloud, and it is not as cool and cloudy as other cloud-native service, but it is still one of my favorite. I use VM mainly for two reasons. First, its versatility. I can deploy any operating system on any hardware. I can install any framework and run any application. Essentially, I can replicate most of the cloud features using VMs if I don't care about scalability or reliability. And VMs also offers a seamless transition from on-prem world to the cloud. Arguably, it is the most important service that make lift and shift possible, for better or worse. And the second reason I would pick VM is for its cost. And deploying application like a web application or database on VMs is always much cheaper than using cloud-native solution. And most of the cloud service providers offer free tiers of VM service. To understand how organizations nowadays deploy their compute resource, I did some analysis. I sampled a subset of 500 US-based companies and look at how they created and deployed their cloud, their compute resource in the past 6 months. And I focus on the three most commonly used cloud resources: virtual machine, container, and serverless. And the results are quite interesting. The number of deployed container service is twice as the number of deployed virtual machine service. The number of the deployed virtual machine service is twice as the function, lambda function. So there are still many VM service in the cloud, but what are the risks of this VM service? What are the attackers' incentive to compromise these VMs? Here are a few, I outline a few incentives here. First, the data. Although it is not the best practice, we still see a lot of sensitive data like secret and plaintext source code stored on VM. And the second is computation. Cryptojacking malware remain prevalent. Although it is old and kind of boring, its low entry barrier and quick for profit still make it an ongoing issue. And third, backdoor. Although VMs in the cloud are supposed to be ephemeral and immutable, we still see many long-running VMs in the cloud. Just for curiosity, I look into the cloud environment we monitor and checked the oldest VMs that are still actively running. And this is a screenshot of those VMs. All these VMs were deployed back in 2016, about 8 years ago. And we can sort of guess the name, guess the function of this VM by their names. There are database, there are controller, probably Active Directory, there are vulnerability scanners, and the names that I found most interesting and amusing are those suffixed with do not touch. These VM have been there untouched for a very long time. And if I were an attacker, I would probably rename the machine I compromised with do not touch. And last, the service account. Service account attached to VM may contain risky permissions. For example, default service account attached to GCP VM usually contain privilege permissions. For curiosity, I pull some stats again and look at all the VM in the environment we monitor. And I want to see how many of those VM are attached with permissions vulnerable to privilege escalation. The data show that 5.5% of the EC2 instance in the environment we monitor have instance profiles vulnerable to privilege escalation. And 8% of the VM in GCP are attached with service account vulnerable to privilege escalation. So the bottom line is virtual machines are still widely used and critical resource that a lot of organizations relies on. So before diving into the attack path into VM, let me first explain about attack path. I've seen many different definitions about definition on attack path, but our definition of attack path is a potential route or method that an attacker might exploit to take over a cloud resource. And it is essentially a more complex form of attack vector. In the rest of the talk, I will go over 6 different cloud agnostic attack paths. The first attack path, and you will see that despite differences in the configuration and usage, most cloud service provider offers the same features. And the first attack path, exploitation of vulnerability, is not really cloud specific. We have had vulnerabilities since we invented computers, but it is still very relevant to VMs in the cloud. And the next 5 attack paths are cloud native, based on they are exploited based on the cloud control plane or platform APIs. The first attack path, exploitation of vulnerability. As I mentioned, this is not really a cloud-centric, cloud-specific attack path. However, it is still probably the most common way that attacker gain control over a virtual machine. And to highlight the likelihood, or to take a look at the likelihood of this attack path, I did some analysis. First, I have a scanner scan the entire internet, look at the cloud-hosted virtual machines, and do some software matching to identify the vulnerabilities on those cloud-facing, internet-facing cloud-host virtual machine. And the data show that 11% of the cloud-hosted virtual machine have critical or high unpatched vulnerabilities. And the second step, I looked into the cloud environment we monitor, and I used the scanning results from software composition analysis, as well as the cloud configuration. And the data show that 43% of the cloud accounts, subscription, or project have internet-facing VM with critical or high unpatched vulnerabilities. So regardless, a virtual machine is internet-facing or internal-facing, as long as an attacker can reach it and exploit a vulnerability, there's a chance that they can take over the VM. The second attack path, manipulation of startup script. When the virtual machine is deployed, it usually comes with the base OS. In order to do something useful on this VM, the users need to install and configuration the software. Startup script automate this process and allow you to deploy and configure a group of VMs without user intervention. And also because startup scripts usually involve configuring, installing software and configuring or modifying system, it usually runs with privileged like root account. If an attacker can inject malicious code into a VM's startup script, the attacker can essentially take full control of the VM. In AWS, the startup script can configure through user data, and in Azure, it can be configured through custom data. In GCP, it can be configured through metadata service. Metadata service is one of the most critical service that is centered to almost all the attack paths that I will explain. A little bit more detail about each cloud service provider. In AWS, to use EC2 user data, by default, the startup script only runs on the first boot. In order to force it to run again, the startup script need to be rewritten in MIME format using cloud init directives. In Azure, the custom data associated with the VM cannot be modified once it is created. So it is not really possible to exploit this feature to compromise an individual VM in Azure. However, the custom data associated with VM scale set can be modified. VM scale set essentially help create and monitor a set of load balance virtual machine in Azure. So if a VM is part of a VM scale set, it can be compromised using this method. And the metadata in GCP, so the startup script in GCP is run on every reboot. So it works a little bit different than AWS and Azure. To configure metadata in GCP, there are two different ways. The metadata can be configured at the project level or at the VM level. When it is configured at project level, the metadata is applied to every virtual machine in this project. And when it is configured at the VM level, it only affects individual VM. The next attack path is SH key push. When there are a group of users who share a set of VM, key management can become quite complex. When a new VM is added, all the users' key need to be added to the VM, or when a new user joins the team, the user's key need to be replicated to every VM. So SH key push features help simplify this process. Using this feature, user can push SSH public key into VM through the cloud APIs without actually logging into the VM. And this feature also handles key management and allow user to log into VM using cloud identities. And under the hood, this feature is implemented using the agents running on the VM that constantly pull the cloud endpoint for the new public keys and modify the SSD config file locally. In AWS, EC2 instance can be implemented. The principal, in order to use this feature, the principal needs the instant connect, send SSH key, public key permission, and the target VM needs the instant connect agent installed. It is a little more difficult in Azure. The principal needs the virtual machine write permission, and the virtual machine also needs VM agent installed. However, VM access is usually not installed by default, so if the VM access is not available, the principal also needs another permission extension right in order to install the VM access. And for GCP, it's quite straightforward. Again, it is just metadata. So SSH key pushes help simplify authentication and authorization into VM. However, sometimes I just want to run code and command in a set of VM without actually logging into those VM. And the direct code execution help with this process. Direct code execution essentially allow remote code execution in the cloud environment. I can use Cloud API to send a piece of code to a VM and run the code in the VM. Because it is such a powerful and potentially risky feature, most cloud service providers make it a little bit more difficult to enable it, requires additional configuration and permissions. In AWS, the SSM run command can allow direct code execution. The principal needs the SSM send command permission, and the target VM needs to have the SM agent installed and also be granted SSM managed instant core role. And in Azure, it is actually quite straightforward. The principal just needs the VM run command write permission, and the target VM just needs the VM agent, which is again installed by default. And in GCP, for this case, it's a little bit more complicated. It requires OSConfig to be installed on the VM, and OSConfig also need to be enabled in the metadata service. And there's yet another way to SSH into a VM. This feature is unique to AWS as far as I know. I haven't found the equivalent feature in other cloud service providers, but so this is one of the really cool ways to SSH into a VM in AWS. It allows users to SSH into a VM that does not have open inbound port. Instead of connecting to a VM using SSH port, this feature the agent running on the VM tunnels the traffic between a VM and a user over AWS network. So I will skip the last attack path. First, for more detail, I have a blog that you can read. But any feedback or comment about VM securities are welcome.
All right, thank you. So I got a question from the phone. You talked about deploying with VMs versus Fargate. How did you do that research and gather that list of data across major companies?
So those are based on our proprietary data.
Gotcha, okay. Oh, cool. Any other questions from the room? All right, well, thank you to our speaker. Thank you to our AV team who's been here all day. They rented their equipment on the spot market, so it needs to be deprovisioned. So we just need to clear out the front of the room so they got space to deprovision. Thanks for coming to Forward CloudSec, and enjoy the rest of your day. Thank you.